Today's topic is Kuka DeviceConnector, which is a way of you to improve your production or your end customers' production by providing the information you actually already have. So what is Kuka DeviceConnector? We call it also KDC internally here at Kuka. It's a software package, and that software package actually provides all the data the robot has into your or your customer's network to use in your application or your customer's application. And as you have already understood, Kuka DeviceConnector is a software option which is installed on the robot controller and belongs with the Kuka software options. And within Kuka, we have a lot of softwares that goes with our robots. And let's have a short look of where this software belongs. And the softwares we have, they are divided into 5 different groups, where we have the operating system, which is essential to make the robots actually work. Then we have a number of system extensions, a number of application-specific softwares, that could be for welding, for example, a number of engineering tools, which would make your integration of your robot application faster and easier. And at the end, we also have a number of cloud-based softwares. So where does Kuka DeviceConnector fit in? Well, as I mentioned, we have a system software, which is essential in all robots and therefore is of course included in the robot delivery. And that we call it Kuka System Software, KSS. And on top of this, we then can have a number of system extensions, which are in many cases sold as options depending on your need. And one such pretty common system extension is, for example, the safety options we have. So safe operation would be one of the system extension options which are available. If we look further on, you see that one of the groups within the system extension softwares is communication, and naturally this is where Kuka DeviceConnector fits in our software model. So Kuka DeviceConnector provides all the data we have within the robot and the robot controller to your network. And it does so by using 2 transfer methodologies. One standard is the Mqtt protocol, which is the dominant standard for providing data according to the Internet of Things applications. The standard which is commonly used and most commonly used for providing Internet of Things applications into cloud services, for example. The other transfer methodology that the DeviceConnector uses is OPC Unified Architecture, which will provide real-time data directly into the network. This means that you can access any data of the robot without going through a third-part PLC, for example, to get the data, which means that you will save a lot of engineering time. And we are using these 2 standard-based protocols to also achieve, well, obviously a cost-effective solution, because these are widely spread, commonly known protocols. They provide a high security level, so these cannot easily be hacked by anyone. It also gives a standardized and easy access to data directly. And equally important is that it also keeps the data traffic in your networks at an absolute minimum. It's not a software that is pouring data into your network. If we mentioned a little bit about what MQTT is, well, first of all, it's a one-way transfer of data. Basically, that means that the data is provided by the robot or robot controller in this case, and then published out to the network. That means that to be able to look at this data, you also need something called an Mqtt Broker, which could be a standard software in any PC, or talked to a customer last week who had actually implemented this in a Raspberry Pi setting in his network. It's a common known software. Then from this broker provide it to whatever client needs the data, a cloud service or so on. And this gives the possibility to reading robot data or reading process variables. And if we now look at the OPC UA, UA stands for Unified Architecture, and that gives the OPC transfer platform an hardware and software independent transfer medium. OPC has, as many of you know, been along for quite a few years now, but the older standards with OPC DA, data access, was limited to the Windows and Microsoft platforms, but OPC UA is open to all platforms. And the data transmission is also bidirectional. That means that we can both receive and send data over this protocol. And again, it's also possible to read both robot data, but in this case, we could also read and write process variables to the robot. So for example, if we wish, we could use this media, the OPC UA interface, to, for example, change recipe parameters in a robot. And of course, both MQTT and OPC UA supports that several different data readers, clients as they also are called, can access the robot at the same time. So what do we use all this information for then? Well, typically one aspect of this is purely in assets management, where we can provide directly the robot information. That is the IP address of the robot, the identity of the robot, that is the serial number, for example, of both the robot and the control cabinet, whatever software and software versions are installed on them, hardware and firmware versions, and so on, just to keep track of what assets we have where in our production. The next and natural step of that is the condition monitoring. That is the robot controller and runtime, for example. That could be temperatures of motors, for example, the running time of the controller, so on. The load data of the robot is pretty important to keep an eye on, of course. And also a lot of dynamic data, like axis position and speed running, or motor torque, and so on. And of course, alarm messages or event logs, equally important to be provided as. And also external communication from the robot, whatever IOs I have connected, or external signals on, or if I have external access controlled by the robot controller. The values for these are also available through the Kuka DeviceConnector. And of course, also safety information. That could be that if the brake test has been done, when it was done, if it was successful, if the robot is in a safety stop, for example. The safety checksum of the robot is also important. All this data here is what we typically use as the direct use cases. This is pure relevant information that you will need directly to analyze. But using all this information that we can provide is also a process where it can be described as 5 steps, which all of you and your customers and we need to grow into to make best use of this data. And all of us are at different stages in this development phase, and even internally we could be at different development stages in the same factory, depending on what type of equipment or process we're talking about. And of course, the first thing we step in this process is to get the data, where Kuka DeviceConnector is the enabler. And of course, then when we get the data into our network, we need to present it in a meaningful way. That could be a local HMI or a centralized HMI or some kind of database access for maintenance, for example, or a cloud service of some kind. And when we now have been able to present the data, we also need to start recognizing the data. We need to analyze the data, learn about them. That is alarm levels, what speeds are we using, and so on. And once we start doing that, recognizing this data or the statuses the data provides, we can now begin to build up our knowledge about our own process, not only the robot, but the manufacturing process. That is, if I produce a certain article, the robot, for in this example, will use this number of seconds to do the movement. It will use a certain energy amount, because we can monitor the current of the robot as well. And we can start interpreting and understanding, building up our knowledge about our process. And when we do that, we can also start developing our knowledge so that we can identify a problem before a problem becomes a real problem. Use it for predictive maintenance. And then we can also use this data when we start making decisions, optimizing our process, doing changes and evaluating the result of that. And of course, for that, we need what we call extended use cases as well here then. What is also provided with Kuka DeviceConnector then is, of course, the possibility to do file transfers to and from the robot, KRL user programs, getting the diagnosis, events and alarms, and so on. Getting all the logs directly out of the robot. You don't need to transfer all the alarms momentarily. If you don't need, you can actually access the logs directly in the robot instead. In your user program, you can now start doing statistical or calculated data as user variables in the program. That could be number of picks done for this product, for example, or calculate the energy used for a certain product per piece or so on, and provide these data then directly into your network. So you can do a calculation of data inside your robot program, which then is available directly through Kuka DeviceConnector. Typically, also start using OEE application, for example, measuring your availability or productivity in your complete robot installation. That is one of the typical use cases where you would like to do that. And of course, I've already mentioned predictive maintenance, which is one of the central applications here, detecting a potential problem before it becomes a real problem. And for this, you need the data which can be provided through Kuka DeviceConnector. So what type of data can I actually get? Well, if I was to start going through data point by data point, it will take all day for us. But it's important to know that the data is basically everything the robot controller has. But it's structured in a pretty understandable way. So it's an object-oriented tree model where we could go up to a object. The top layer object is either the robot or the controller. And then we can start breaking down that structure into robot information, installed tag packages, firmware versions. But then below that, we have the strict runtime variables, such as energy usage, engine, motor temperature, motor axis, motor torque, loads, and so on, which are dynamic data, which changes during the operation. All these are broken down into a clear tree structure, so you can easily find the information. And typically, you can see it. This is an example of these structures which you would find, and OPC UA actually displays the data in this tree structure. So when you browse into the robot with a use OPC UA client, you will get a tree structure like this of your data, and then you just select the data points you're interested in. A lot of work of what data is really relevant to use in your analysis has been done by the VDMA, a German workshop association, which has tried to standardize which data are relevant, and they're in a standard called VDMA 4010, and has set up a requirement out of suppliers of what data they should at minimum supply to be able to bring out relevant production data. And of course, Kuka DeviceConnector supports this standard. And for those of you who are curious, in the GoToWebinar control panel, there is a tab called Handouts. And under this Handout tab, you could find this standard. So you could yourself read what data is included in this VDMA standard. And the data points, which are specified in the VDMA standard, are listed as mandatory or optional. That means that the mandatory data points are required of all suppliers which adhere to the standard, and the optional can be provided as an option or are not really required out of the supplier. We can provide all the data, both the mandatory and the optional data points, which are listed in the standard. And this is just a screenshot of the specification, which you can find under the handout for those of you who are interested. Standards are always a bit of a dry read, but this is not too heavy to read. How does this now fit into our structure? Well, Kuka DeviceConnector, and the current version is 2.1. It's a software installed on your robot controller, sitting in the network, connected to your network. And it can now start providing useful data directly to, for example, you probably have some need for information locally on your cell HMI. Could be alarms, for example, positions of the robot, running modes. At the same time, we could also provide data directly to central monitoring you have in your network on your factory site, displayed on screens in your production room or your maintenance office, or directly as and-on screens in your production. Any type of central monitoring, providing runtime data or availability data or information for both direct or predictive maintenance. This can all be done within your factory walls in your production directly, but the same software can now also provide the same data to whatever cloud service perhaps you need. And this cloud service could be either within your factory or externally used. And this could be an Mqtt provider, which fits into any cloud service you may already use. Or we could also use, through a network bridge, the OPC UA transfer protocol, also to an external platform, if we like. So the flexibility of DeviceConnector is quite outstanding, I would say. And of course, Industry 4.0 is actually what Kuka DeviceConnector is about. to make use of the information we already have. And the steps I described earlier could be better described in this pyramid, actually, where we start off with the connectivity, how to get hold of the data to actually start using them. And that is what Kuka DeviceConnector is about. And then starting to get some transparency of the operational factors in your or your customer's production. Alarming, availability analysis. And after that, start building knowledge about the production in terms of anomaly detection. Something is not quite as it should, but it's not an error yet. And this is also the base for the next step, where Kuka are very active in terms of machine learning, artificial intelligence. So instead of you and I sitting and doing this anomaly detection, the system itself can start detecting the anomalies. But the enabler for this in the Kuka world is Kuka DeviceConnector, which pretty much brings us to our last slide. Kuka DeviceConnector is a product in our product portfolio, and it has 3 licensing levels. And the first licensing level is actually something called Kuka DeviceConnector pre-installed. It is actually installed on all new robots we supply. And what does this do then? Well, it gives you the possibility to examine what signals are available. It will display the signal structure and what values are available, but it will not give you the value itself. So it's a teaser, a browser to see what you can find. Then there is the standard Kuka DeviceConnector, which is a software license you buy from Kuka. And it will provide all the mandatory data points according to the standard I mentioned earlier, VDMA 4010. But it is also limited to those values. You can see all the other values which may be available, but you cannot read them. And the third and final license level is Kuka DeviceConnector. And I've written standard in my PowerPoint here, which is wrong. It should be full, of course, which is also a license from Kuka. And it provides all the information that is available, not only the VDMA standard, but all information available in the standard. And it's both license files, so standard and full, is a one-time license. And the full version gives you all the access, including all your program variables that you want to make accessible through the net.
Industrial intelligence.